Okay guys, here's my new simulator. I've got these particles connected so that they can see themselves with this button on. This little triangle means that they can see themselves. The blue can see themselves, the red, or the gray, or the green. And they can also see other particles or not. Right now, blue cannot see red, gray, or green. And now, nothing can see blue. So blue is its own little simulation over here. He doesn't see anything, doesn't react with anything, nothing sees it. He's just kind of overlaid on top of the world and invisible to the world and sees nothing of the world. So in this way we can create really cool simulations and observe different effects. So let's add him back in here, and first I'll show you the symmetry here. So let's turn them all off. They can only all see themselves now. So it's kind of hard to get anything interesting when this happens because the simulation is very sparse. Particles aren't next to each other. They can't see the other particles. So what I do to compensate is I increase the velocity a little bit so that they collide with other particles, and then I can also increase the beta up to like 23. And sometimes that helps. Let's go to 30. That's still too sparse. Let's add a little bit more ability to see each other. Okay, now we have the red and the gray interacting with each other. Let's turn up some alpha blending. Oh, there we go. Blue and green are reacting with each other, and the red and the gray are reacting with each other. But as you can see from this graph here, only these two see each other, and they don't see anything into the blue-green. So they are still their own little separate simulations. But let's do something different. Let's connect them with a bridge. So now gray can see this whole system via this link here. So here I see gray interacting with blue. Here. Let's let the green system and green-blue see back to this gray-red system. I got some green and red reacting with gray. Look at these regions here. The blue and the gray tend to clump together, as do the red and the green. That's kind of weird. The blue and the gray clump together. Oh, I see what's going on. These are the only two that don't see each other directly. So they can be their own little sort of off to the side system, and they don't interact with each other. So they just fill up the space. And same with green and red. They fill up their space, and they don't interact with each other to clump in those spaces. That's kind of cool. I bet you if I added a link here, that would stop happening. It takes a while, but I'm still seeing the red-green symmetry between their spaces and the blue-gray in their spaces. Oh, maybe it's because, yeah, that's it. There's still no link here. Let's add some links between blue and gray. Okay, now the blue and the gray clumps disappeared. Or sorry, the space, the nutrients of the blue and gray disappeared. But we still have no link between green and red, so they are happy sitting next to each other to fill in the space where there's no clumping involved. Let's add one directional seeing. The red can now see green, Oh, so now that makes the red clump. He doesn't want to be next to green anymore. He is rejected from the green nutrients. But the green is not, he doesn't see red and he still is happy to be by himself. Let's change that. Okay, now every particle is symmetrical with every other particle. We have equal amounts of nutrients in the red, green, blue, and gray. And we get these big clumpy amoebas. Okay, I was experimenting earlier and figured out how to reject one color from this big amoeba. Let's see if I can remember that. Let's make nothing see blue. Is that what I did? Nothing sees blue except for himself. Blue sees himself, but he's rejected from the big amoeba. Now nothing sees blue, but blue still sees these other particles. Blue doesn't even see himself at this point. So we did that with blue. Let's see if we can do the same for green. Should be a symmetrical system. Yes, green got rejected. Mostly. There's still a few inside the big amoeba, but here we can see it's mainly on the periphery, green. Back to normal. Circular loop of seeing. Let's cut out green. Green only sees itself here. If I turn this off, green will stay frozen, sort of, just oscillating between two positions, each little particle, because it doesn't see itself. Let's do this. Ooh, that's interesting. I call these wisps, and they happen when a particle doesn't see itself, but it sees lots of other particles. Here it's got a large velocity, so we don't see the wisps, but let's slow it down. What's my beta at? Beta's at 30. Let's try to put it back down to the normal 17. Back to the wisps. It's interesting that I still get the wisps here, but here there's just, it sees too much. It wants to move around a lot. I could change the radius of everything and probably get those wisps. So the brown sliders, they control globally the other particles. So they control red, green, blue, and gray, like the beta, the radius, and the velocity. But if I want to increase only the parameter on green, say velocity, then I can change only green. It scales it. Let's turn one of these off so we get the wisps back. Those are kind of interesting. No wisps. Wisps. So blue and red like to react with each other. I'm not sure if there's some gray in there or not. It's kind of hard to see. Let's turn up the alpha plating. So we get some gray and red reacting here. Some blue and red reacting here. Is there ever blue and gray reacting? No, there's not. Looks symmetrical. Let's try this. Everything can see red. Red can see itself. Unfortunately, it's not dense enough for red to do anything on its own. So maybe we can increase red's beta and velocity to get it to react with itself. Nope. Let's try that on green. Nope, that makes sense. Particles are symmetrical. Let's increase the beta back to 30 to get things interacting again. There we go. Got some interactions. It's interesting, oh, there's blue. Okay, I was going to say it was interesting only gray was reacting, but sometimes these things take a while to get going. We are, after all, watching evolution in progress, and sometimes, like in our situation, it took millions of years to watch these things evolve. It's interesting that green is not clumping, though. Let's try this. Get the spark of life for green. There we go. I nudged it a little. So beta is at 32. Let's increase only the beta for green. Well, that didn't work. Ooh, let's slow this down. What's going on here? Looks like red is the only one. Red happened to get the spark of life, and it's the only one that seems to be moving around here. Why is everything else not moving? That's kind of interesting. Is that his defaults for everything, as is everyone else. That's what's so cool about this thing is sometimes you get a different random initial condition and things just progress from there, and you kind of gotta reset the system and do the big bang all over again to get different behaviors. Let's see if we can change it. There. Now red's not interacting anymore. There we go. So I just gave it a little nudge. So, whoa, what happened? Everything slowed down. Did I do that? I guess I set it back to default. There we go. Okay, let's. So now blue and green. Huh. I caused green to interact with itself. If I turn it back off, green is still interacting with itself. So let's see if I could do that with red. I should be able to. Make sure these are all defaulted. So green reacts. Huh. All right, let's reset everything. Okay, everything's reset to the beginning when I first started the video. Oops, no, it's not. Let's go back to connecting everything together. Okay. Blue and gray decided to evolve together. Not sure why green and red aren't getting involved. Let's let it run for a while and see what happens. Once I had a bug in my simulation and some really cool stuff happened, but I didn't want to lose the behavior. It was kind of neat, but I had to fix the bug, and so it's kind of made me think about our own universe, and I wonder if they're like, I won't call them flaws, but what if they're little exceptions to the rule in our own universe, and that creates really neat behavior, and without that flaw, we might not even exist if that flaw is part of our permanent equations in the universe. It really makes you think. So I can't explain this. I cannot explain why red and green aren't behaving just like blue and gray, but blue and gray decided to form a symbiosis. I think maybe once these clumps occur, they are kind of self-sustaining, and maybe that's what happened when I hooked all these things together. I think I hooked blue and gray first, and green and red last. So let's hook blue and gray last and see what happens. And let's sort of mix up the particles by exploding them out. There we go. Sort of get a random background noise, some cosmic background radiation going. Okay, now we will connect blue and gray last. Let's see if red and green form a symbiosis. Nothing formed a symbiosis. Let's try that again somehow. Let's increase beta to 23. Seems to be a magic number. Yeah, gray, blue. Okay, now we're going to connect gray and blue last. Still we get gray and blue together. Okay, this will blast them apart, I'm sure. Now they are wisps. Are these defaulted? Huh. I can't get green and red to react with each other. Let's go back to normal. Okay, now green and red have to react. See green reacting. Increase the velocity. See what's going on. Slow it down. Increase beta back up to 23. I can't explain it. You can get blue and gray to react somewhat. So blue and gray are their own little simulation, not involved with red and green. And blue and gray seem to react together. Let's check the code and make sure this is experiment 40. The ratios are in equal proportion for green. I have the radius and velocity set here, so the others should be the same. 5 and 1.34 for blue, 5 and 1.34 for red, 5 and 1.34 for gray. Okay, let's go back to this configuration. It looks like a lot of static noise now at this point. It's like I broke them forever, but I know that can't be true. I should be able to cause them to sort of crystallize back into their interacting cells. So shortly after this video, I will show the same video for the heartbeat that I found, and also the one of galactic proportions with beta equals -3. But I just wanted to show the system here so you knew what to look for in those videos and how things are connected. I spent last week making the little mouse clicks, turn these guys on and off, and changing their interactions. So I guess I will leave it here for now. Have fun simulating your own digital life at home, and I'll see you next time.